Okay, so for number 40, again, these are a bunch of exponents. What we're going to do is the power 2 of the power you multiply. So this becomes a to the negative 6. Then you're going to put the power of 2 on each one, a to the 6 b squared. And then again, 4 times 3, it becomes b to the 12. Now, because I'm multiplying, I'm going to go look for all of the variables that have the same base, which is I have a's and b's. So I'm going to add my exponents on the a's. Negative 6 plus 6 becomes a to the 0, which then just becomes 1. Then I'm going to go back and add my b's. 2 plus 12 gives me b to the 14th. So 1 times b to the 14th, and the final answer here is just b to the 14th. Now for the next one, you can either simplify what's inside the parentheses, or you could distribute the negative 2 to each of them. It doesn't really matter. If you want to flip it, like I can flip this to the reciprocal and then simplify. I can go ahead and put the negative 2 on everything. So this will become a to the negative 2, b to the negative 4, c to the positive 6, over 2 to the negative 2, a to the negative 4, and b to the positive 8. Now what I can do is I could move around the negative exponents. So I can move the a's, switch their spots. So this 2 to the negative 2 will go to the top. A to the 4 will come to the top. A squared goes to the bottom. B to the 4th goes to the bottom. B to the 8 stays there. And C to the 6 will stay there because it's already positive. Now this is still a 2 squared. Now you could have also subtracted the exponents. It really doesn't matter. So 2 squared is going to give me 4. Then for the a's, I'm going to subtract them, 4 minus 2. So then that's going to give me a squared. Then for the c, it's just going to stay in the top. And then the b's, they're going to stay in the bottom. I'm just going to add them. And you're done. So 4a squared, c to the 6, b to the 12. Okay, so for number 51, it says to factor completely. So for 51, I can factor out a greatest common factor of 2xy. So let me go ahead and rewrite the problem. 2x squared y minus 6xy squared. I'm going to divide them by my GCF, which is going to be 2xy. My GCF, I'll write it here. And then in the parentheses is going to be what results after I divide. So after I divide the first term, the only thing that's left there is an x. And then the second term is going to be 3y. And you're done. For number 53, a nice easy trinomial. We're looking for the factors of negative 14, that when I add them, I get positive 5. And those factors are going to be x plus 7 and x minus 2. Remember, on any of the factoring questions, you can FOIL it and make sure it does go back. If it doesn't, then potentially you could have picked the wrong signs or the wrong factors. Then number 55, you can either do factor by grouping here, or you could guess and test. I'm just going to guess and test because the factors of 3, it's only going to be a 3x times 1x. And then the factors in negative 1 are just going to be positive 1 and negative 1. You just have to FOIL it and make sure that once you place them, that it does FOIL and give you the middle term. And if I do a quick check here, my outer gives me negative 3x, my inside gives me positive 1x, and then when I combine them, I do get the middle. So that is the factors of that one. Now you could have also done factor by grouping. Then number 56, I will factor by grouping on this one. I'm going to multiply the beginning and the end, and this gives me negative 72. So two numbers that multiply to give negative 72, but who will add to give me 1. And those factors are going to be negative 8 and positive 9, because the bigger factor is the sign of the middle. So again, I'm going to rewrite my first term, which was the 6x squared. Then I'm gonna replace the middle with the two factors I just found. It doesn't matter how you put them in here. You're still gonna get the same answer either way. And then now I'm gonna make my groups. I'll make a red group and I'll make a purple group. My GCF of red is gonna be 2x. So 3x minus 4. And then my GCF of purple will be 3. And again, you're left with 3x minus 4, which is the goal, to make sure that these two are the same. And then you're left with 3x minus 4. And then also group the two GCFs you divided by. So this is the answer to number 56. Okay, so now 57. 4t squared minus 13t minus 12. This one I'm not going to guess and test on. I'm actually going to factor by grouping. So I'm going to be multiplying 4 times negative 12, and I get two numbers that are going to multiply to give me negative 48, but who will add to give me negative 13. So 48 has a lot of factors, so let me start my organized list. My middle term is negative, so my bigger factor will be the negative. So 1 times negative 48, 2 times negative 24, 3 times negative 16. And that's the combination that I need. So again, I'm going to factor by grouping by rewriting the first term. And then I'm going to replace the middle term with the two factors I just found. Doesn't matter the order you place them in here. You will still get the same answer either way. And now I'm going to make my two groups. So I'll make a blue group and a purple group. My greatest common factor of the blue is going to be 4t. Divide. And then my greatest common factor of purple is going to be 3. I'm going to take the two GCFs that I just divided by. That becomes my first binomial. And then the second binomial is what they have in common. And then you're done. And this is the answer to number 57. So for number 59, what we're going to do here is also one other thing that you always need to remember is always look for a greatest common factor first. None of the other ones that I factored so far had a GCF between all the terms, but this one does. So I can divide this by 4. And then now I'm left with factoring 4 minus t squared, which is the difference of two squares. So I'm going to factor it into 2 minus t and 2 plus t. And you're done. Do not forget to write that GCF in front of the final answer. For number 60, 2y to the 6 minus 32y squared. On this one, I can just pull out a greatest common factor. I'm going to divide it by 2y squared, and then I'm left with y to y. I'm going to be left with y to the 4th minus minus 16. Now, however, I have the difference of two squares, so I can keep going here. So 2y squared still is on the outside, then a y squared minus 4, y squared plus 4, and then I can keep factoring. 2y squared, y plus 2, y minus 2, and then the sum of two squares can't be factored any further. So this would be the final answer here for number 60. Okay, so the next one is number 60, but again, you won't need to worry about a question like that, so you can skip that one. So then number 62, this one has a to the 4th, b squared plus a b to the 5th. So the only thing we're going to do here is we're going to factor out a GCF first. You should always look for a GCF first. So my greatest common factor here is going to be AB squared. So after I divide each of my terms by AB squared, I'm going to be left with A to the third plus B to the third. This is the sum of two perfect cubes, so I can keep going here, and I have to do my SOAP pattern. So I would need to cube root this and cube root this and put it into the SOAP pattern. So don't forget about your GCF. So the cube root of A to the third is just A. Cube root of B to the third is just B. Remember, SOAP acronym, same sign. Then in the trinomial, it'll become A squared. Then opposite sign, then A times B. And then the last term, always positive, and it's going to be the B squared. And then that would be your factored polynomial here. Again, remember, the trinomial that results after you factor a perfect cube cannot be factored any further. Okay, so the next page, number 63, we have another perfect cube. This is the difference of two cubes. So for number 63, I have x to the third minus 27. So I'm going to cube root the x to the third. I'm going to cube root the 27. So I'm going to put it into my SOAP pattern. The cube root of x to the third is x. The cube root of 27 is 3. And then I'm going to put it into my trinomial now. I square the x, opposite sign of the original problem, multiply the 3 and the x, and then the last term is the 3 squared, which is 9, and it's always positive. For the next one, number 64, I'm going to go ahead and factor out a GCF first. So my original problem is 3y cubed minus 81x to the third. So I could factor out a GCF of 3. So I could show I'm dividing by 3. And then what's left is y to the third minus 27 x cubed. This is the difference of two cubes, so I need to keep going. And again, I'm going to do my SOAP pattern. So again, I'm going to cube root the y to the third, cube root the 27 x to the third. So don't forget about the GCF. Put that 3 there first. Cube root of y to the third is y. Cube root, same sign here, of 27x to the third is going to be 3x. And then in the trinomial, we need to square the y. Opposite sign of the original problem, multiply the 3x and the y. So that middle term becomes 3xy. And then last term always positive with that 3x squared. So it'll become a 9x squared. And we're done. For number 65, for this one, I'm going to factor by grouping. So I'll start 65 over here. So I have 4x to the third minus 8x squared plus 3x minus 6. I'm going to make two groups. It doesn't matter how you group them. I'm grouping them the way it was written. My GCF here is going to be 4x squared. So I'm going to divide it by 4x squared. And then I'm left with x minus 2. And then I need to find the GCF of the blue group, and that's going to be 3. So plus 3, and then divide. Notice you get the same thing. So this is now really becoming a GCF. And then take the two numbers you divided by, your GCFs originally, and they become the second binomial. And we're done with 65. So for 66, I'm still going to factor by grouping. I'll move over here. So I have 3x to the third minus 2x squared plus 18x minus 12. I'm going to make my groups. I'll make a red group and a blue group. My GCF of red is going to be x squared. So I'm going to divide by x squared, and I'm left with 3x minus 2. My GCF of the blue group is going to be 6. And then I'm left with 3x minus 2. Again, take the two things that you divided by, those GCFs, put them together, as well as what is in common now. So then it becomes 3x minus 2. And that's the answer to number 66. Number 69, I'm just foiling it. So once I do first, outer, inner, last, first gives me 4y squared. The outside gives me 14y. The inside gives me negative 14y. And then finally last gives me negative 49. Once I combine the two middle terms, notice they're going to cancel out. And then you're just left with 4y squared minus 49. And that's number 69. Then 72, I'm going to factor a GCF out of the numerator. And what's left is x squared plus 2x plus 3 over the x. And again, I can simplify these x's. And then what remains is my final answer, which is just the numerator, x squared plus 2x plus 3. For 73, I'm just going to FOIL it. So first gives me 2x. Outside gives me negative 1x. Inside or inner gives me 2 square root x. This needs a square root. And then finally last gives me negative 1. I can combine the two terms in the middle. And my final answer is 2x plus the square root of x minus 1. For 76, I need to factor that difference of 2 cubes and the difference of 2 squares. So for 76, I'm going to first factor the top and factor the denominator. So the top is a perfect square, or the difference of 2 squares. So it is going to factor into t minus 1, and then t squared, opposite sign, t, and then always positive with a 1. And then the denominator will factor in difference of 2 squares, t plus 1, t minus 1. The t minus 1's cancel, so final answer on number 76 is going to be t squared plus t plus 1 over t plus 1. Remember, these are attached, so do not try to cancel out part of that trinomial. You will get it wrong. For number 77, I'm going to factor each one of the pieces. So for number 77, I'm going to first factor in this numerator. So the factors of negative 3 that give me positive 2 are going to be x plus 3 and x minus 1. The denominator, factors of 16 that give me 8, it's actually a perfect square trinomial. This will factor into x plus 4 and x plus 4. It's a binomial squared. But I'm going to leave them apart just to make it easier for simplifying. And then the numerator, I can pull out a GCF here of 3. So what remains here will be 3 and then x plus 4. The denominator cannot be factored, so I'm leaving it alone. Now I'm going to look for things to simplify. I can simplify an x plus 4. I can simplify an x minus 1. And that is all that can be simplified. So the final answer on 77 is going to be 3 times x plus 3 over x plus 4. For 78, same thing. I'm going to need to factor each piece. After I factor them, I'm going to need to do a keep, change, flip. Now, I'll go ahead and do a keep, change, flip first, just so I don't forget to do it. So let me go ahead, set this up as a keep, change, flip. So change it to multiplication. And now I can go ahead and begin to factor. So I'm going to factor this numerator. Factors of negative 15 that give me negative 2 are going to be x minus 5 and x plus 3. The factors of the denominator of positive 5 that give me negative 6, and that's going to be negative 5 and negative 1. No, that's going to be negative. So negative 1, negative 5. And then over here, I can factor the difference of two squares. This becomes x plus 1, x minus 1. And then lastly, the denominator over here becomes factors of negative 12 that give me negative 1. That's going to be x minus 4 and x plus 3. Now I'll look for things to simplify. I can simplify the x plus 3's. I can simplify the x minus 1's and the x minus 5's. And then what remains is x plus 1 over x minus 4. So the final answer on 78 will be x plus 1 over x minus 4. Remember, these are attached, so don't try to cancel the x's. All right, so for number 82, remember whenever you're adding and subtracting, factor first. So I'm going to factor this denominator. This is going to turn into x plus 2 and x minus 2. This denominator over here can factor into x minus 2. Go ahead and change the color here. Let's do this in blue. Okay, so I'm going to factor this one into x minus 2 and x plus 1. So this one's going to have three different binomials as its common denominator. So my common denominator is actually going to be x plus 2, x minus 2, and x plus 1. That's my common denominator. So over here, this one, the very first one, is missing the x minus 2 and the x minus 1. And since I'm timesing that by 1, let me just go ahead and put it here. And then I have the plus sign. The middle one is just missing the x plus 1. So 1 times anything is just itself. So that's just going to be an x plus 1 there. Then the last one is missing the x plus 2. So that last one is missing an x plus 2. Now this 2, I can keep change it, and I'm going to distribute a negative 2 to the x plus 2. Now, here's where I've been seeing a lot of mistakes, is a lot of students are canceling things at this point. We need to FOIL this. I need to distribute this and combine like terms before I can start looking for things to simplify. So if I FOIL this right here, it actually is going to go back to this denominator of what it was. So this is actually going to FOIL into x squared minus x minus 2. I still have the red, and then I have to distribute this negative 2. Now I still have the same common denominator. And now I need to add my like terms in the numerator. There isn't anything to add to the x squared. However, I can go back and I'm going to add my x, my negative x, my positive x, that's gone, and then minus 2x. So now I'm just left with a negative 2x, and then I'm going to go back and grab my constants. Negative 2 plus 1 is negative 1, minus 4 is negative 5. And then now it's over the x plus 2, x minus 2, and x plus 1. And we're done, because there are not any factors of 5 that will combine to give me negative 2. So that would be your final answer. Then number 84 is that complex fraction. Again, simplify the numerator by finding a common denominator and subtracting. Simplify the denominator by finding a common denominator and adding. So for the red, 1 over x minus 1 over x plus 1, my common denominator here is going to be both. You can't just add a plus 1 to the first fraction. So the first fraction is missing the x plus 1. The second fraction is just missing the x. So now I need to combine my numerator, and I end up getting 1 over x times x plus 1. That's my simplified numerator. For the denominator, I'll do this one in blue. So it's 1 over x plus 1 over x plus 1. Common denominator is both. So my first fraction, what was missing was the x plus 1. The second fraction is missing the x. So I'm going to multiply that to the top and the bottom. Now when I add this numerator, I'm adding 1x plus 1x, and I get 2x plus 1. So now I have in my denominator 2x plus 1 over x times x plus 1. Now I'm going to do a keep flip change, keep the red. Flip the blue upside down and multiply. So now the blue flipped upside down becomes x times x plus 1 over 2x plus 1. And again, look for things to simplify. The x's simplify, so do the x plus 1s. And then I'm just left with 1 over 2x plus 1. So for number 90, we have to rationalize. Remember, you can never ever leave a radical in the bottom of a fraction. So I'm going to multiply by the opposite expression of the denominator. So I'm going to multiply top and bottom by 3 plus the square root of 2. I'm going to distribute the 14. So this gives me 42 plus 14 square root 2. And then whenever you multiply the denominator by an opposite expression, you're just doing first and last. So I get 9 minus 2. So now I have 42 plus 14 square root 2 over 7. Now remember, on these problems, when you're trying to simplify, this 7 needs to be able to divide into both of the numbers in the top. And it does. This becomes a 1, this becomes a 6, this becomes a 2. So your final answer here is 6 plus 2 square root 2. If you factor out a GCF, then you would get 3 plus square root 2. And that's it for number 90. Okay, so for number 5, A, B, and C all look very similar. But notice on part A, that negative sign is not being held in. So you can either think of this as a negative 1 times 2 to the 6th. And 2 to the 6th is going to be 64. So really it's negative 1 times 64. So part A is negative 64. However, part B, whenever you have a negative number held in parentheses and it's raised to an even exponent, the answer will always be positive. And when you have a negative exponent, remember, it doesn't make the number negative, it makes it into a fraction. So this will be 1 over 64. And then for this one, we're going to flip to the reciprocal, make it positive, and then this becomes 4/9. Okay, so for H, notice the negative exponent. So this tells me it's going to become a fraction. So I'm going to move the whole thing underneath the 1, make the exponent positive. Remember, the denominator is the root. The numerator of the exponent is the power. So it's going to become the 4th root of 81, and then I'm going to cube it. So the 4th root of 81 is 3, and then 3 to the 3rd power is 27, so 1 over 27. Then for the next one, in order to add and subtract radicals, they need to have the same radical, sort of treat them as variables. So I'm going to break down the 20 into 4 times 5, and then the 125 into 25 times 5. Then 4 is a perfect square. This will simplify to 2 radical 5. And then same thing here, 5 radical 5. I now have like radicals, so now I can subtract 2 minus 5, and my final answer is -3 square root 5. The next question is, just says perform the indicated operation here. So all we're gonna do is square this. So remember, you can't just put the exponent of 2 on the 2x and on the 3. We either need to memorize the pattern or write this down 2 times and FOIL it. So let me go ahead and FOIL this, and I end up with 4x squared plus 6x plus 6x plus 9. I can add the middles, and then I end up with 4x squared plus 12x plus 9. Over here, I'm just multiplying these 3 terms. And again, remember, multiplication is commutative, so it doesn't matter the order. So I'm going to go ahead and multiply, and I'm going to FOIL these 2 because this is going to end up turning into the difference of 2 squares. And then I'll go ahead and distribute the x squared. So once I FOIL this, it ends up being x squared plus 3x minus 3x minus 9. Notice the middle terms, they cancel out. So then you're just left with x squared minus 9. And then now you can distribute the x squared, and then you get x to the 4th minus 9x squared. And you're done. My next question is a subtraction. So again, remember, whenever you're subtracting, we need to find a common denominator, but I need to factor this denominator first. It's going to factor into x plus 2, x minus 2, and that's going to be my common denominator. So the first fraction is already set. It has everything it needs. So let me just put the x squared on top. Now the second fraction, though, it has the x plus 2, but what it's missing is the x minus 2. So again, whatever you're going to multiply to get into the bottom, you also need to multiply to the numerator. So up here, I still had the x plus 1 originally, and now I'm going to multiply it with an x minus 2. So I need to go ahead and do not try to cancel anything at this point. We need to FOIL or multiply this first and then combine it with that x squared. So once I go ahead here and FOIL this, I end up with x squared minus 2x plus 1x minus 2. Combine the middles, and it becomes x squared minus x minus 2. So let me go ahead and rewrite this all together. And now also remember, see this subtraction sign? I need to distribute the subtraction sign into this trinomial. So before I put in the denominator, let me go ahead and distribute it. So it becomes x squared minus x squared plus x plus 2. Notice here, these will cancel. And now I'm left with x plus 2 over x plus 2 times x minus 2. The x plus 2's cancel. I'm left with a 1 behind. So my final answer is 1 over x minus 2. And then the last question, the last page here, we do have a complex fraction, and then we also have a question that we need to rationalize. So I'll go ahead and take care of this fraction. I need to find a common denominator. Okay, so let me go ahead and find a common denominator of the numerator. So my common denominator is going to be both x and y. So this first fraction was missing the y. So this becomes a y squared. The second fraction was missing the x. This becomes an x squared. So now I have y squared minus x squared over xy. And then I also need to do the same thing for the denominator. So again, my common denominator is xy. And I'm subtracting here. So this one again is missing the x. This one's missing the y. So then this becomes x and this becomes y. So now here's my main fraction bar. And I'm going to subtract the numerators over the common denominator. And now I'm going to do a keep, change, flip. So I keep the red. Now I'm also going to factor the red. The red will factor into y minus x and y plus x over xy. I'm going to flip the blue. and it becomes y minus x. So now I can multiply. Notice the xy's cancel. And then I can also cancel these because they're opposite, change this to a -1 and this to a +1. So now what remains is going to be negative y plus x. You can either leave it like that or distribute the negative sign. So either answer here is acceptable. And then the last question is a rationalize. So I have the square root of 10 over the square root of 5 minus 2. In order to rationalize, I'm going to multiply by the opposite expression. And I'm going to distribute. So then this becomes the square root of 50. But if you think about it, the square root of 50, I'm going to break this down into 25 times 2. So this will actually be 5 radical 2. And then I'll distribute the square root of 10 to the 2. And then put it over, and again, I have to FOIL here, but really all I'm doing is first, which gives me a 5, and then last, which gives me -4. So then now I have 5 square root 2 plus 2 square root 10 over 1. And again, you don't need the 1 in the denominator, so you could just leave it as 5 square root 2 plus 2 square root 10, and you're done. And that is it for the review.